Objective 5, piecewise defined functions. Consider the function f of x equals, we're defining this to be 2x when x is less than or equal to 0, x plus 1 when x is between 0 and 2, equal to, not 0. And then once we get beyond 2, we'll use this definition, 3x. We want to find f of negative 2. Now this is self-defining here, that x equals negative 2, so we have to figure out which inequality is satisfied. Well, at negative 2 is less than or equal to 0, so it looks like we're right here. And then we'll use the 2x definition, 2 times negative 2, or negative 4. F of negative 1, x equals negative 1. Negative 1 is still less than or equal to 0. Notice negative 1 is not between 0 and 2, and negative 1 is not beyond 2. There should be only one inequality satisfied. So 2 times negative 1, negative 2. F of 0, 0 is less than or equal to 0, still in the first part of the domain here. And then when we get to f of 1, 1 is in between 0 and 2, so we're going to use x plus 1. So 1 plus 1, or 2. F of 2, x equals 2, so we're in between 0 and 2, equal to, so we'll use x plus 1. 2 plus 1, or 3. And finally, we get to f of 3. 3 is beyond 2, and so we're going to use 3x. And so we have 3 times 3, or 9. That's a basic piecewise defined function. These are valuable for calculus. When you're studying the definition of the derivative, this will come into play. But piecewise defined functions are also useful in physical sciences. Many times we can't find one expression to fully express a whole range of physical phenomena. So things are broken down into discrete definitions. Now the more interesting part for this course is graphing such a function. And suppose we have a function f of x equals, let's make up a different one, x squared, x less than or equal to 0, 2x, 0 less than x less than or equal to 2, and x minus 4, x greater than 2. We'll use the same split domain, but we have different functions. The whole key to this graphing this will be the table. And in your homework on a test, you must have a table. If you just draw a picture, that'll lead me to believe you got it off of a graphing calculator. The table shows you have a full understanding of how this works. And that's what we're not interested in drawing pretty pictures. We're interested in understanding these basic concepts. So what we're going to do is start with this x less than or equal to 0 part, and I'm going to let x be negative 2, negative 1, 0. Now what I'm going to do is just copy this x squared down here. The reason is it's nice to have the function right here rather than taking this number, going back here, transferring the result here. It just makes it a lot easier. Now 0 to 2, I'm going to do 0, 1, and 2. And there I'm going to use 2x. But the problem is for 0, we're really up here, we're not down here. This is a false point. I'm going to circle that to remind us of that fact, but it will help us to draw the graph nonetheless. And then we get beyond 2. We have this function x minus 4. Beyond 2, we're going to do 2, 3, and 4. And we have the same dilemma at x equals 2. We're really up here, but we have this false point. So we're going to do this. And now we can substitute negative 2 squared, 4, negative 1 squared is 1, 0. Now our times 2 function, 0, 2, 4. 2 minus 2, 0, 3 minus 2, 1, 4 minus 2, 2. Okay. And now we're going to draw a graph. We need x to go from negative 2 to 4, and y has to go from, well, between 0 and 4 in any event. So we'll make our nice Cartesian coordinate system. And x goes from negative 2 to 4. And y goes from 0 up to 4, 2, 3, 4. You can add one more for good measure. And we're going to plot negative 2, 4. We go over 2, up 4. And then negative 1, 1 is right here. And then 0, 0 is right here. And keep in mind we have a parabola, so it has some sort of curvature to it. We have the left side of the parabola. And then now we have 0, 0 is a false point. I'm going to put this false point here. It will serve a purpose. And then we have 1, 2. And then we have 2, 4. Which is right here. My kitty's making an appearance. Here, kitty. Here, kitty. Say hello to the class. Hello. And we'll connect the dots. It's supposed to be a straight line. It's a little bit crooked, but you get the idea. This gives us something to connect up to. You see the function has, as it goes from 0 to 2, it has to be defined for all the decimal numbers like 0.1, 0.2, and 0.3. And this gives us something to connect to. Let me straighten my line there a little bit. And then we have 2, 0. It's another open circle. And then 3, 1. 3, 1 is right here. And then 4, 2 is right here. We go to there, and we have to continue. The arrow indicates it continues. Again, that's supposed to be a straight line. My scale got a little bit off. Straighten that out a little bit. And that's how we graph one of these functions. If there's 3 parts to the domain, there should be 2 open circles. The open circles are always where the less than or greater than are. One little definition here. Notice this graph continues down here, stops here, continues from there. This section of the graph is what we call continuous. But there's a jump here between here and here, and we say this is discontinuous at x equals 2. It's when there's a break in the graph. If you trace with your pencil all the way through, if you ever get to a point where you have to lift your pencil off the paper, there's a discontinuity. This is an important calculus concept that you'll investigate much more fuller in calculus. If you get used to some of the visual aspects of this here, then it'll make more sense. That's all for Objective 5. We'll be back with Objective 6.